Hello and welcome to this course on model predictive control. This week we are talking about state space MPC. In the previous video I had recapped what we have done in dynamic matrix control as well as in linear quadratic control. And in this week what we are going to do is take those concepts and look at state space MPC implementation. So, what is the plan for the rest of this week? We are going to first take the deterministic case. Again, in the deterministic case, I will talk about ideal system, just x equal to ax plus bu, y equal to cx, and then we will start adding more and more things to it. For example, measured disturbances, unmeasured disturbances. We will then talk about disturbance modeling. That will then lead us into the stochastic case. We will talk about the disturbance modeling, requirements for convergence and stability. And then we will finish off spending maybe up to an hour on using MPC toolbox. MPC toolbox will automatically do one or more of these things for you already. So, that is what we are going to do in this rest of this week. Okay. So, let us talk about state space MPC. First the deterministic part, and we will only look at the ideal case where we do not have the disturbance component in it. So, we are not yet looking into this particular part. Okay. So, before going further, let us define what our yp k plus 1 is. Yp k plus 1 is yk plus 1 at k yk plus p at k. Okay. Our um k is uk plus 1 and so on up to uk plus m minus 1. Okay. And delta umk is just going to be delta uk plus 1, delta uk plus m minus 1. Okay. So, these are the definitions that again we are familiar with, we just wanted to refamiliarize. Okay. So, let us now use this particular model and use the future model predictions as we have done in the LQ control part. The first part we did a batch derivation, the same way we are going to follow, but the difference is in the LQ control we looked at prediction of x, here we are going to look at predictions of y. Okay. So, as we had in the previous slide, we need yk plus 1, yk plus 2, yk plus 3 and so on, right. So, yk plus 1, and I will just drop this particular part, given k part I will just drop it just to avoid writing too many things. So, yk plus 1 is going to be nothing but c times xk plus 1. Okay. Now, c times xk plus 1 is nothing but c multiplied by axk plus buk, which is equal to ca xk plus cbuk. Okay. So, this is what yk plus 1 is. Okay. Yk plus 2 is nothing but c times x k plus 2, okay, which is going to be nothing but c times ax k plus 1 plus buk plus 1, okay, which is going to be equal to something. We then can go on up to y k plus p is c times x k plus p, and let us try to find out what those are. Okay. So, let us look at the next guy. What we have is x k plus 2 is nothing but ax k plus 1 plus bu k plus 1, okay, which is nothing but okay. Now, this is x k plus 1, x k plus 1 is nothing but ax k plus buk, okay, and this is going to lead us to a square xk plus abuk plus bu k plus 1. Okay. This is what xk plus 2 is going to be. Okay. So, let us put this in a square x plus abu plus bu. Okay. So, c times a square x k plus abuk plus bu k plus 1. Okay. So, this is what our y k plus 2 is going to be. Now, let us look at x k plus 3, a x k plus 2 plus bu k plus 2. So, that is a multiplied by this guy that we have over here, which is a square x plus abuk plus bu k plus 1, right. So, this a will take it inside and this becomes a square x k plus becomes a cube x k plus a square b u k plus a b u k plus 1, and now we have this particular term plus b u k plus 2. Okay. So, now you can probably see some pattern emerging. Again, we have done this before. So, we can write this down. A k plus p is nothing but a to the power p x k plus a to the power p minus 1 b u k plus a to the power p minus 2 b u k plus 1 and so on up to b multiplied by u k plus p minus 1. Okay. So, this is what you are going to get. So, let us put this over here. It is just c multiplied by all of this. So, it is going to be c a to the power p x k plus c a to the power p minus 1 b, c a to the power p minus 2 b and so on up to c b multiplied by u k plus 1 and so on to u k plus p minus 1. Okay. So, this is what we get. Okay. So, now let us use this in order to build our model prediction equations of this form. Okay. In order to build model prediction equations of this form, this is what we are going to do. Okay. Our yp k plus 1 is going to be equal to nothing but c multiplied by a x k, c a squared a multiplied by a x k, c a cubed and so on up to c a to the power p. Okay. So, that is what we are going to have c a squared, c a cubed, c a to the power p multiplied by x k plus we have this entire box which is going to be c b multiplied by u k plus 0 multiplied by u k plus 1 plus 0 multiplied by u k plus 2 and so on, right. So, c b 0 0, then we have c a b 0 0, c a square b, c a b 0 and so on up to c a to the power p minus 1 b, c a to the power p minus 2 b okay, multiplied by UP k, right. So, it is a U k plus 1, k plus 2 up to k plus p minus 1 and not k plus m minus 1. Okay. But we want to get this in terms of delta u. Okay. Why delta u? We have gone over that earlier. The reason is that we want to have integral action, and that is the reason why we put it in terms of delta u. Okay. So, how do we put this in terms of delta u? Now, if you look at, for example, over here, if you look at basically this term, right. Let me change the color, change it to purple color. If you look at this term, this is nothing but uk minus 1 plus delta uk. Okay. So, if we take this, what are we going to get? So, this, the first guy is going to be CB multiplied by uk minus 1 plus delta uk, okay, which is going to be nothing but CB multiplied by uk minus 1 plus CB multiplied by delta uk. Okay. That is going to be our first guy. Okay. Now, let us look at this. What is this going to be? This is going to be nothing but AB multiplied by uk minus 1 plus delta uk, and this is going to be B multiplied by uk minus 1 plus delta uk plus delta uk plus 1, right. Okay. So, what is that going to lead us to? The second row is going to lead us to CB multiplied by uk minus 1, okay, plus CB multiplied by delta uk. Okay, plus CB multiplied by delta u k plus 1. This is basically representing this term, okay. But we also have this particular term which is going to evaluate as plus CAB multiplied by CAB multiplied by uk minus 1 plus delta uk. Okay. So, this is what you are going to get in row number 2. Okay. So, let us write down what we are going to get in the top row. The top row we are going to get yk plus 1 is Ca times xk plus Cb times uk minus 1 plus Cb times delta uk. The second row is going to be yk plus 1, yk plus 2 is nothing but Ca squared multiplied by xk. Okay. Now, you will have Cb multiplied by uk minus 1 plus Cb multiplied by delta uk plus Cb multiplied by delta uk plus 1, okay, plus Cab multiplied by uk plus 1 plus Cab multiplied by delta uk, not k plus 1, k minus 1 plus Cab multiplied by delta uk. Okay. So, we can combine this in this form in this way, right. So, what we are going to have? We are going to have Ca squared x plus Cb plus Cab uk minus 1 plus CB plus CAB delta UK plus CB multiplied by delta U K plus 1. Okay. So, this is essentially what you are going to get. Okay. If you do the same thing for third row, you are going to get CA cubed X, okay, plus the next term is going to be CB plus CAB plus CA squared B multiplied by UK minus 1 plus the same thing multiplied by delta UK. Then you will have CB plus CAB multiplied by delta UK plus 1, and finally you will have CB multiplied by delta UK plus 2. Okay. So, again all these derivations you can do them on your own and you can verify. So, what do we have? Again we have CB multiplied by UK minus 1 okay. Then the next row we have CB plus CAB multiplied by UK minus 1. Next we have CB plus CAB plus CA square B multiplied by UK minus 1, and finally we have summation I equal to 0 to P minus 1 C A to the power I B. Okay. Now plus we have this big bracket multiplied by delta UMK. Okay. So, what is the first guy going to be? First guy is going to be CB, next is going to be 0, 0 and so on up to 0. Okay. What is this guy going to be? It is going to be CB plus CAB over here, and then we will have CB over here, we have 0 over here and 0. The third one is going to be CB plus CAB plus CA square B. Okay. Then we will have CB plus CAB, this is going to be CB and then 0. Okay. Okay. Now, what is this guy going to be? This guy is going to be the same one as before, I equal to 0 to P minus 1 C A to the power I B. This is going to be equal to I equal to 0 to P minus 2 C A to the power I B and so on. This is going to be summation I equal to 0 to P minus M C A to the power I B. You can see how it very nicely forms that structure. You have C A to the power I B summed over multiple guys in each of those elements. It goes from 0 to P minus 1 in the first column, 0 to P minus 2 in the second column and 0 to P minus M in the last column. Okay. So, you can take pen and paper, rederive this and you will be able to see that you will be able to rederive this quite easily. So, again it is not very difficult, just follows straightforward linear algebra principles. Okay. And this is your overall equation. Okay. So, this is the case when you have ideal situation, that means, and this one is Sx, this one is Su pre and this one is S capital. Okay. And these are the three matrices that are of use to you. Okay. So, it kind of follows the same trend, it follows the same pattern and you can derive this fairly easily. Now, this is fairly restrictive in the sense that we cannot expand it to cases of disturbances. So, I can just expand it to the cases of measured disturbances. Now, the question is, what we are going to take up next is, where do these measured disturbances come from? I will take this up in the next video.